Now, let's take a look at the commit processing. Transaction states and modes, commit record, CR backlog, and commit steps. Okay, transaction state, you're either in a transaction or out of a transaction. In all cases, the gem has a consistent view based on a single object table. So whether you're in a transaction or out of a transaction, you have a view of the database. Then there's a transaction begin mode. The begin mode for the transaction is either autoBegin, that is, we begin a new transaction automatically. Every abort or commit starts a new transaction. So in that, if you're in autoBegin mode, then you're never out of a transaction. There's manualBegin, where an abort or commit ends the current one, and you need to explicitly begin a transaction. Finally, there's something called transactionless, which is used only for gems that are quiet, that are not doing anything. Now, we've discussed the object table is associated with a commit. A commit record represents a view of the repository. So with a view of the repository, you have an object table as modified by a particular commit. The commit record also holds a list of the objects created or modified by a particular commit. So with each commit record, each time you do a commit, there's a list of the objects that have been modified. There's also a list of the pages that have become shadowed by this commit. So again, objects will have been moved to a new page, and so this is a list of the old pages that are holding shadowed objects. That's all part of a commit record. Every gem session is connected to exactly one commit record at a time. Now, multiple gems can have the same commit record. So if two sessions log in at the same time, they will both get the current, most recent commit record. That's the way, when you log in, you get a view of the database. And a view is associated with a commit record. So when you log in, you get a commit record. If someone's done a commit, they've created a new commit record. And if you do an abort or commit, then you'll get moved up to the latest commit record. Now, if there's a commit record for each commit, and if there's lots of commits, then you can end up with a lot of commit records. And that, of course, is a significant overhead. Want to avoid that if we can. Some commit records might not be directly referenced, but we still have to preserve them if there's anything older that's referenced. So again, if we go back and look here, gems 1 and 2 are referencing commit record 1. Gem 3 is referencing commit record 3. We can't get rid of commit record 2 because in order to commit, gems 1 and 2 will have to look at the commit record for 2 and 3 to see if there's any conflicts. So the commit record includes a list of the pages that became shadowed. Now the pages will still exist in the repository and possibly in the shared page cache. Each commit record has only the pages that got shadowed by its commit.
So if you had something that was shadowed in commit record 2, when gem 1 and gem 2 stopped using commit record 1, those shadowed pages could then go away at some point after that?
Yes. Yes. They would become eligible to be garbage collected. Yes. Shadowed pages can be reclaimed using the reclaimed garbage collection process, but they cannot be reclaimed. So if commit record 2 shadowed some pages, then commit record 1, gems 1 and 2 are still looking at those pages and need to keep them available. So yes, these gems are looking at this commit record, which may include pages that are no longer, that have been shadowed. And once they release, so once commit record 1 is no longer being referenced, then the pages on commit record 1 that are shadowed can be eligible for reclaiming processing. If 1 is referenced, then 2, we need to keep those pages around. But once 2 is no longer needed and there's nothing older than it, then the pages on 2 can be reclaimed.
So currently long transaction is terrible.
Long transactions are evil. Yes.
Yeah, right.
Yes. Long transactions are evil. Now, actually rephrasing that, long transactions on a system that has lots of transactions are evil. You could have one commit record that sits with one session for an hour and nothing happens. If nothing happens, then you have one commit record. If you have 10,000 commits per second, then you need to be aborting, you can't hold a commit record for very long. You shouldn't have any transaction that's longer than a few milliseconds if you're going to have 10,000 commits per second. Commit record backlog is a problem. A big commit record backlog is a problem. So, Gem 1 is referencing commit record 1. Gem 2 is referencing commit record 5. 2, 3, and 4 are still needed as long as 1 is being referenced. So reference commit records must be held. Subsequent to referenced ones must be held.